Good morning, students. I am Mrs.Sweetly, working as an assistant professor of civil engineering department in Emmanuel J.J. College of Engineering. Today, we are going to study about the force couple system. Now, I am going to explain the force couple system by using one problem. The question is, the figure shows two vertical forces and a couple of magnitude 20 kilonewton meter acting on a horizontal rod which is fixed at A. Determine the resultant of the system. Second, reduce to force couple system at A. Okay, the figure is given in your question. It shows it is a cantilever beam. How you identify the beam as cantilever? Because one end, A end is fixed and the D end is free. Therefore, if the beam is supported at one end or fixed at one end and other end is free, then the beam is said to be cantilever. Here the given beam is cantilever. The total length of the beam is 4 meter. Here two point loads are acting, one at D and other at B. At B point, the point load of 40 kilonewton is acting, and at D, the point load of 60 kilonewton is acting. And here we have another one load at C. That load is a couple moment because the value is 20 kilonewton meter. Okay, which indicates the couple force. Couple force of 20 kilonewton meter is acting at C. The direction of a couple force is clockwise. I hope you all know what is meant by clockwise and anti-clockwise rotation. Here the rotation is clockwise. Therefore, the value is positive 20 kilonewton meter. The question they asked to find the resultant of the system and second force couple system at A. What is meant by resultant force? The summation of all the given forces is equal to the resultant force. Here two point loads are given, 40 kilonewton and 60 kilonewton. Both are acting downward. If the force is acting downward, then we have to take the sign as negative. If the force is acting upward, then the sign is positive. Here both forces are acting downward. Therefore, we have to consider the sign as negative. First of all, we are going to calculate the resultant force of a system. Okay, the resultant force is indicated by capital R. Capital R is equal to two forces are acting downward. Therefore, minus 40 minus 60. Therefore, the total value is minus 100 kilonewton. Therefore, the resultant force magnitude is 100 kilonewton and the direction is downward because the value 100 is negative. The negative sign indicates the direction is downward. Here note that we didn't consider a 20 kilonewton meter load at C. Why we didn't consider it? Because it is a couple force. Okay, it is a couple, therefore we didn't include it while calculating the resultant forces. Okay, while taking the moment we have to include the couple moment or a couple force. Okay, then we are going to find where the resultant force is located. Okay, at which distance we have to locate the resultant force. How you find the location of resultant force? It is find out by using the Varignon's theorem. What is the Varignon's theorem? The algebraic sum of moment is equal to the moment of resultant force. Okay, here we are considering the algebraic sum of moment at A. Okay, which is equal to the moment of resultant force about A. For that, we are going to calculate the moment at A. Okay, how we calculate the moment? If the load is a point load, you have to take load into distance. Okay, therefore see the diagram. Here 60 kilonewton is present at D. We have to include the distance from D to A. Okay, load into distance. Vertical load means you have to take the horizontal distance. Therefore, load into distance. First, we are going to calculating moment about A. MA is equal to the 60 kilonewton load is acting downward, which means the rotation is clockwise. Therefore, positive plus 60 into distance from D to A is 4 meter. Therefore, 60 into 4. Next, one couple moment is acting at C. It is acting in a clockwise direction. Therefore, sign is positive, plus 20. Then at B point, 40 kilonewton load is acting downward. Its direction is also clockwise. Therefore, plus 40 into load into distance. For point load, load into distance. The distance from B to A is 2 meter. Therefore, plus 40 into 2. Is it clear? Moment about A is equal to 60 into 4 plus 20 plus 40 into 2. Okay. Therefore, you get the value as 340 kilonewton meter. The value is positive. Therefore, the rotation is clockwise. Then we are going to use the Barrignon's theorem for calculating the distance at which the resultant force is acting. Therefore, algebraic sum of moment about A is equal to moment of resultant force about A. For moment about A is equal to resultant force R into X. Okay, moment of resultant force, which means force into distance. Here we are taking the distance as X. We already find out the moment about A. The value is 340 kilonewton meters. Substitute the value in place of moment about A. Therefore, 340 is equal to, already we calculate the resultant force, R is equal to 100 kilonewton. Therefore, 100 into X. From that, we get the value for X is 3.4 meter. Therefore, we find the distance at which the resultant force is acting. The value is 3.4 meter. Therefore, the resultant force 100 kilonewton is acting downward at a distance of 3.4 meter from A. Okay. Then in the question they asked to find out the force couple system at A. Therefore, we have to consider a beam carrying a resultant force. Okay, we already find out the resultant force and the location of resultant force. Therefore, you have to draw a beam carrying a resultant force at a distance of 3.4 meter, which means the x distance. Okay, then the equivalent diagram is next diagram. See the figure B. We are considering the resultant force at a point M. Okay, M from A, the distance between A to M is 3.4 meter. At A point, we are calculating the force couple system at A. Therefore, you have to consider the A point, and at the A point, you have to consider 100 kilonewton load in both upward and downward direction, which means it is the equivalent force. Okay, the value remains 0 because in both direction the same load is acting. The magnitude of the force is equal to the resultant force. It is acting in both upward and downward direction. Why we are considering at a point A? Because we are going to calculate the force couple system at A. Therefore, we are considering a point load 100 kilonewton, which is equivalent to the resultant force in both upward and downward direction. Okay, then next see the C diagram, which is the equivalent force diagram. It shows the force couple system at A. How you calculate the couple? At A point, we have to consider the resultant force 100 kilonewton acting downward. Then how we calculate the couple? Couple force is equal to 100 into 3.4 load into distance. Okay, which gives the couple moment 340 kilonewton meter. Okay, is it clear? In the question, they asked to find out the force couple system at A. Therefore, at A point, we have to consider a force equivalent to the resultant force in both upward and downward direction. Then, find the couple by using resultant force into distance. From that, we get the couple. Therefore, in the C diagram shows the force couple system at A. I hope all of you understand the force couple system. Thank you.